So I have these two matrices and I want to multiply them. I want to find the product of these two matrices. How do I multiply them? So what I'm going to do here is that you're going to multiply them in this way. If I have this matrix, before you check for the multiplication, check for the other dimension. A is a 3 by 3 matrix, and then B is a 3 by 3 matrix. Before you can multiply two matrices, make sure that the number of the columns of the first matrix is the same as the number of rows of the second matrix. So assuming that maybe I have a matrix A which is 3 by 2, then if I'm going to multiply it to a matrix maybe B which is a 2 by 3, this would work because the number of columns here and the number of rows here are the same, right? If they don't have the same number of columns, I mean the first matrix do not have the same number of columns as number of rows of the second matrix, then you cannot do the multiplication. Okay, so the other way to also look at it, another key thing is that after the multiplication, the product would have a dimension of this too. Okay, so after the multiplication, what we're coming to do is 3 by 3 multiplied by another 3 by 3. The product will have a matrix of the form 3 by 3. I mean this by that. On the other hand, this case, if we had a 3 by 2 and then a 2 by 3, and the end product or the final answer will have a 3 by 3 matrix. So assuming if I have A which is 3 by 1 multiplying B which is maybe 1 by 3, because this and this should be the same before you can multiply them, then the final answer should be a 3 by 3 matrix. Alright, so let me clean this and then talk about how to multiply matrices. So how I'm going to multiply these things is that I'm first going to pick the whole row 1 of the first matrix, multiply everything by column 1, and what I'm going to do is I'm going to do them entry by entry. Okay, so I pick the first row. First entry is 1. I multiply by the first entry in the first column of the second matrix, and that is 0 plus 2 multiplied by 3, that is 6 plus, okay, let me write it, 6 plus 3 multiplying 1, and that's going to be 3. So that's the first entry of my final result. Then I go to the next entry. The next entry is going to be that same first row multiplying the second column. So it's going to be 1 times 1 here, which is 1, plus 2 times 2 here, which is 2, plus 3 times 3, which is 9. And then the next entry again is going to be the same first row you have multiplying these columns. It's going to be 1 times 2, that is 2, plus 2 times 4, which is 8, plus 3 times 5, which is 15. And I'm done with the first row. Now I go to the second row. I pick these 4 times 0, which is 0, plus 1 times 3, which is 3, and then 1 times 1, which is plus 1, right? So I'm going to do for all of them. Now if I do the second row times the second column, I'm going to have 4 plus 1 plus 3, and then that same second row times the last column, and that's going to give me 4 times 2, which is 8, plus 1 times 4, which is 4, 1 times 5, which is 5. And then I do that for the last row. So I'm taking them row to column like that. Now 0 times 0, I'm going to have 0. Remember, we are doing this and this first, and then 1 and then 3, plus 3, 2 times 1, which is 2. Now go to that this last row to the second column here. I'm going to get 0 plus 3 plus 2. Well, let me see. 0 times 1, that is 1 times 1, which is 1. So here is 1, and then 2 times 3, that is 6. All right, I'm so sorry. Then I have 0 plus 4 plus 10. Sum these, and whatever you get is your final answer. So I'm going to get 6 plus 3, which is 9. 12 here. This guy is going to give me 25. This is going to give me a 4, and this is going to give me 8. This guy is going to give me 17, I guess. This is going to give me a 5, and that's going to give me 7. This guy is going to give me 14, and that is the product of these two matrices, right? And if you look at this very carefully, I can write a general form of it. If I assume that A has each entry to be Aij, and then maybe B also have entries, maybe same Bij, or maybe let me call it Bij again. Okay. Then I can say that the product of A and B, I'm going to write final the final answer. If I have AB, each little entry of AB, these guys that you want to get, is going to be the summation as k start from 1 to n, where n is the number of column, or maybe a number of rows that you can think of. Maybe number of rows in A and a number of columns in B. AIK and then BKJ. What this whole thing means is that, now let's come to A1. This guy is the 1 entry of AB. So if I want AB 1 is going to be 9, right? And what this is saying is that that should be equal to summation as k start from 1 to some n, and I'm saying that n is either the number of rows in A or the number of columns in B, and in each case it's 3. I'm going to have A1k and then BK1, right? Because J and I are both 1 here. Now I want to pull it down some more for you to see what I'm trying to do here. I'm going to use this for a general proof in maybe some of our next lessons. So this summation, what it means is that as k starting from 1, I'm going to have A1 1 B1 1 when k is 1, right? Plus when k is 2, I'm going to have A1 2 B2 1. Plus when k is 3, A1 3 B3 1. Now if you look at this very carefully, you realize that this A11 B11 is 1 times 0, and that is what we had here, 0. So I have 0 plus A12 is the first row, column 2, and that is 2 times B21. B21 is the second the second row and then the first column, because 2 is the row and then 1 is the column. So the second row, which is this guy, and then the first column, I have 3. I'm going to have 2 times 3, that is 6. So I had 6 there, plus A13, which is 3 times B31, and that was 3 times 1, which was 3. So that gave me 9, right? So it means for a product of two matrices, ABIJ is equal to the summation as k start from 1 to n. I'm saying that k is either the number of columns or number of rows in the first matrix, so A, or the number of columns in the second matrix, B. And then I'm going to have BKJ. So this is something you should keep. All right, so now let's go to the next problem we can talk about. So here, given that A is 2 and then whatever we can think of, we want to write a relation between the product of A and B and then the matrix given C, right? So here we're going to use our idea in terms of matrix multiplication to solve this kind of problem, right? So what I'm going to do is I'm going to find an expression for AB in terms of x. So I'm going to look for AB, and that's going to be the matrix 2x 3 1 multiplying 2 1 1 4. And like I said, if you do this very carefully, it's going to be 2 times 2, which is 4, plus x times that, so we're going to get x plus 4 here. or maybe 4 plus x, whatever you want to do. Then the next entry is going to be the same, 2 times 1 plus x times 4. So we're going to get 2 plus 4x. And that is that. You are done with the first row. So I'm done with this guy. Now go to the next row. So 3 times 2, which is 6, plus 1 times 1. So I'm going to get 7 here. And then 3 times 1, which is 3, plus 1 times 4, which is going to be 7 as well. And so that is the first part A. Now the next part is to determine the value of x given that B transpose A transpose is equal to C. I've not talked about transpose yet, but I mean, I'll prove that in some of our next lessons. I think our next lesson is going to be on transpose, which I'll prove this, that B transpose A transpose is actually equal to AB transpose. And what do I mean by transpose? Transpose means that you want to take all the row entries you have in your matrix, write them as a column, and then all the column as a row. So what this means is that I know that my AB is this, and so I'm saying B transpose A transpose is actually the product AB transpose. And so I'm going to transpose the product AB. What I'm going to do is I'm going to pick this whole row here, or maybe you can pick column, whatever you want. I'm going to pick this whole column here, write it as my first row, x plus 4, and then 7. And then I'm going to pick the second row, write it as the second column, write it as the second row, and then 7. Right? And I'm saying that this guy is actually called C. That is the B part. And C is 3x plus 2, and then 7 here, 7 minus x. And this makes sense because if we did equality of matrices in our first lesson in matrix operations, and we realized that these entries should be the same, and this makes sense, right? So the only other part to do is to make sure that the first entries are also the same, or maybe these ones. So you can pick any of them and solve for x. So I'm going to have if I bring this 3x to the other side, I'm going to have negative 2x equals 2 minus 4. That's going to be negative 2, and in this case x will be equal to 1. So the value of x in this problem is 1. I hope that makes sense, right? So thank you, and see you in our transpose lessons. I'm going to write some basic proofs as to why this is true, and then other properties of transposition of matrices. See you.